Surface area. Working with three-dimensional shapes, we're often interested in the surface area, or how much stuff could cover a 3D object. This is different than volume, which fills a 3D object. In other words, we're painting the barrel, we're not filling the barrel with paint. A very big difference. Now with surface area formulas, sometimes these formulas start to look ugly the way most people teach them. Okay, got it. Surface area cylinder, 2 times the radius times pi plus the height times the circumference, and the circumference is 2 times the diameter, or the diameter is 2 times the rate. It can get a little intense. I'm going to reduce it down to the same 3 types of shapes we saw with volume, and each one has only its own equations. So first, the prism. We've seen prisms before. Prisms have the same shape on the bottom and the top. Bottom and top are relative. They're just the bases that are connected, and that shape goes all the way through. It doesn't matter what shape that is. All of them have the exact same formula for surface area. And that formula is 2 times b, the area of the base, plus the perimeter of the base, times the height. 2b plus ph. That's a good formula to commit to memory. The second type, again, is very similar. The pyramids or the cones, we've got some type of polygon shape on the bottom. But then all of them are going to come to a point at the top, making either a pyramid or a cone. And the surface area for these is the base times the base plus 1/2 times p, the perimeter of the base, times L. And L is a new variable for us. L is the slant height. That's the distance diagonally up the shape, or the diagonal slant is the slant height. And sometimes we'll have to use the Pythagorean theorem in order to find that slant height. All right, last shape then is the sphere, the round ball. And its formula is actually the most simple of all. It's just 4 pi r squared. So let's take a look at examples. Same examples we did with volume, but this time instead of filling them with paint, we are going to paint them on the outside. This first one's a cone. The surface area of a cone is equal to the area of the base plus 1/2 times the perimeter of the base times the slant height. We might have to work a bit to get those pieces, but we can do that. First, the base. The area of the base. The base is a circle. 12 is the diameter, but the radius is 6. In fact, I'm going to put the radius over to the side here because we're going to need the radius being 6 over this direction in just a minute. So, the base is a circle, pi r squared. Pi is 3.14. R, the radius, is 6 squared. 6 squared is 36. And then I'm going to go to my calculator to find out what 3.14 times 36 is, and that's going to be 113.04. The other variable I need is p, the perimeter. The perimeter of the base, it's a circle. The perimeter of a circle is also called the circumference. That's pi times the diameter, or 3.14 times the diameter here we know is 12. So 3.14 times 12, the perimeter is 37.68. One last piece we need to dig out, and that is the slant height. L, the slant height, we're going to have to get that off the Pythagorean theorem from the right triangle formed in the center. So a squared is 6 squared plus 7 squared equals the slant height squared. 6 squared is 36. 7 squared is 49. So 36 plus 49 is 85. Take the square root of both sides, and the slant height is equal 85 square root on the calculator. The slant height is equal to 9.22. We now have all the pieces of the original formula. We just have to plug them in. The surface area is equal to the base. The base we found out was 113.04. Plus 1/2, I'm going to put that in as 0.5 to make my calculator easier, times the perimeter, which is 37.68, times the slant height, which is 9.22. And then we just have to calculate all that up on our calculator. If I don't have a scientific calculator, I have to do that multiplication first. I do, so I'm going to do 113.04 plus 0.5 times 37.68 times 9.22, and I've got my surface area for this cone is equal to 286.74 centimeters squared. So we do have to do a little bit of work to get all the pieces of our surface area formula, but the formula is the same regardless of the shape of the base. Similarly, the next time, the second shape here we have is a prism. And a prism we know is 2b plus ph. B is the area of the base. The base is a triangle. So the area of the base is a triangle formula 1/2 times the base times the height. The base and the height have to meet at a right angle. So those are going to be 7 and 6. So the area of the base is going to be 21 centimeters squared. The other thing we need is P, the perimeter of the base. So the base has sides 7, 6, and 8. We can add those together. 7 plus 6 plus 8 is the perimeter of the base. That's also 21, ironically. And we already know the height of the prism is the distance that connects those two bases. It's 18 centimeters. So let's go to our formula and plug in what we know. Area is equal to 2 times the base. The base area we found out was 21. Plus P, the perimeter, which we found out was 21, times the height, which is 18. I can type this on my calculator. 2 times 21 plus 21 times 18. And we find out that our area, I'll stick it up above, 420 square centimeters. That's a 0, 420. That's a bad 0. 420 square centimeters is the surface area of this prism. One example left. This is a cylinder. We know the formula for the surface area of a cylinder is 4 pi r squared. This one's going to be the easiest, actually, of all of them. The area is 4 times pi, which we know is 3.14. The radius here is 10 squared. So we have 4 times 3.14 times the radius squared, which is 100. And we just have to plug that into the calculator. 4 times 3.14 times 100 is, we'll put it on top just like everything else was put on top. The surface area is 1,256 square meters. So surface area, it's really 3 formulas. And then you have to dig out the pieces based on what we know from our prior study of geometry. Take a look at the homework assignment, give it a good go, and let your instructor know if you have any questions as you calculate the surface area of these shapes.